Good evening, Titans, and welcome back. This is Mr. Simpson, and hopefully you had a great spring break and you're ready to finish the year strong. Essential question is, how can you multiply and divide square roots? And in this lesson, in this part of this lesson today, we're going to really just work on simplifying radicals and looking at a couple properties of radicals. So the first core concept here, so in your notes you want to make sure you have the product property of square roots, and if you look at it in words, the square root of a product equals the product of the square roots of the factors. So in numbers, if you have the square root of 9 times 5, that product is underneath the radical. We can break that up into a product of radicals, so it's the square root of 9 times the square root of 5. And hopefully, if you remember our perfect squares, the square root of 9 is equal to the whole number 3. So then we can just simplify that into 3 times the square root of 5. Now, in algebra, it's the square root of a times b is equal to the square root of a times the square root of b. And again, a and b must both be greater than or equal to 0 because we're dealing with square roots. So if we look to see how we can use this to our advantage, well, in the square root of 24, there are two ways that we can do this. This first way is to list the factors of 24. So we could have 1 and 24. We have 2 and 12. We have 3 and 8. And we have 4 and 6. Are there any of those pairs where one of the pairs is a perfect square? And if we look, 4 times 6, 4 is a perfect square. So I could rewrite this as the square root of 4 times the square root of 6. Now the square root of 4 is a perfect square, so this could simplify as 2 times the square root of 6. Now that's one method, and that's the method where we find the largest perfect square factor of the number that's underneath the radical. And then we simplify it from there. Now I'm going to show you the second method, which is what we will use most of the time. So what we're going to do is we're going to do the factor tree like we did in class today. So this is 2 times 12, 2 times 6, 2 times 3. And so what we have now is we've rewritten 24 as a product of its prime factors. And we're going to look for pairs because we're doing a square root. So there's a pair of 2's. So the square root of 2 times 2 is just the whole number 2. So on the outside we bring out one number of 2. And then the numbers that are underneath the radical stay underneath the radical. And 2 times 3 is 6. And so we have that as our answer. Number 2 would be the very similar type of thing, but we just leave the radical, or excuse me, the negative out in front with the answer. And now we're going to look at number 4. And we're going to have variables involved in this. And this is actually the square root of 75 n to the 5th. And so again, the first thing we do is do the factor tree for 75. So that's 3 and 25. And then we'd split up 25 into 5 and 5. So then I'd rewrite this as 3 times 5 times 5. Then I have n times n times n times n times n. Right? And all that's underneath the radical. And again, because we're doing square roots, I'm going to take pairs of factors. So there's a pair of 5's, one pair of n's, and another pair of n's. Now again, when we pull out that pair, only one factor goes on the outside of the radical. Then there's an n, and here's another n. And then underneath the radical, we're going to have left 3 and an n. So my final answer is 5n squared times the square root of 3n. Alright, now we're going to look at the quotient property of square roots. And the quotient property just states that the square root of a quotient equals the quotient of square roots. So again, if we look at the first example with numbers, the square root of 3/4 can be rewritten as the square root of 3 all over the square root of 4, which equals the square root of 3 all over the whole number 2. And one of the things you're going to learn about simplifying radicals is that a radical is in simplest radical form when two things are true. 1, there's no perfect square number that's underneath the radical, and 2, there's no radical in the denominator. So the first thing we're going to look at is this first example here. And we're just going to break this up. So the square root of 23 over 9, I'm going to rewrite as the square root of 23 all over the square root of 9. Now the square root of 23 cannot be simplified any further than that. But the square root of 9 is a whole number 3. And then that's our final answer. So now we're going to look at one with the variables. So I'm going to look at number 8 here. So I'm going to first break that up in the square root of 4x squared over the square root of 64. Now, if I know there's a perfect square underneath the radical, I don't believe I need to use the factor tree. So the square root of 4x squared is just 2x. The square root of 64 is 8. And now I can reduce that because 2 and 4 can reduce. So this just becomes x over 4. And there's my final answer. Alright? And the last type we're going to look at are cube roots. So we're not going to change anything. We're still going to do the factor tree. So we're going to do the factor tree for 54. So that's 2 and 27. That's 3 and 9. And that's 3 and 3. So I'm going to rewrite it as the cube root of 2 times 3 times 3 times 3. But now because there are triples, or we're doing cube root, we're looking for triples. So there are 3 3's. So the cube root of 3 to the third is just the whole number 3. So when I bring that out, whole number 3 on the outside, and then it's times the cube root of 2 underneath. And that's the answer to example 1. Now we're going to go ahead and just skip right to number 4. And again, we're going to break this up, first of all, into the cube root of 25 c to the 7th d to the 3rd all over the cube root of 64. Now, we're going to rewrite this. So this is the cube root of 25 is 5 times 5, and then we have c times 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 d times d times d. And then on the bottom we have the cube root of, and if we do the factor tree for 64, we have 8 and 8, 4 and 2, 4 and 2, 2 and 2, and 2 and 2. So we have 2 times 2 times 2 times 2 times 2 times 2 times 2. Oops, not too many there. So now, again, we look for triples. So there's a triple, there's a triple, and there's a triple. So remember, only one factor from each of those sets comes to the outside. So that'd be c squared d, and then step left underneath the radical would be 25c all over. Here's a pair, and here's a pair. So then 2 times 2 on the outside would be the whole number 4, and there's your final answer. So again, when you're doing cube roots, you're going to do the factor tree, and you're going to write out the variables, raised to the power, and you're going to look for triples. Now, if it was to the 4th root, we'd look for groups of 4. So now is open your book to page 279 and complete the problems 1, 4, 5, and 10. We'll go over these tomorrow in class.